Right, so we're trying, so this is section 4.1. Let's do what we can for 25 minutes. So how do you graph? Now it's more of this graphing stuff. It's a good little kind of refresher for what you're about to test on. What if they gave me y equals x squared? You all probably have already on your you have your 3x5 cards ready? You got 20 minutes if you don't have it ready. Feel free to cut out a piece of paper that's about 3 inches by 5 inches and write whatever you want on both sides, but I assume that most of you have it ready to go. So anyway, so on there might be y equals x squared. Probably a good thing to put, or maybe you already know that one so you didn't bother. That's the U shape, right? Okay, and then of course we can move it and twist it and all the stuff we do. What happens if we raise it to the 4th power instead of 2nd power? Yeah, it pulls it up faster, but basically it's the same thing. It's another U shape, it just goes up faster, so it ends up looking thinner, but really it's just going up faster. But for all we care about, it's basically another U shape. Now remember what x cubed is. That one will be on today's test, right? Be a snake. I mean, it might be. I don't even remember exactly, but it's fair game for today's test. That's the snake graph, x cubed. What if we raise that up to the 5th power? Guess what it's going to look like? Same thing. Just going to go up faster, down faster. So you see all the odd powers, any odd power, 3rd, 5th, 7th, whatever, they're all snakes, aren't they? Whereas all the even powers, they're U-shapes. So we're just extending the basic idea that we've already seen. Why do odd powers go up and down, but even powers just go up? You know, huh? Because if you plug in x, positive or negative, to an even power, it comes out positive. It's all going up. Whereas odd powers, negatives will stay negative and go down. All right, so anyway, that's all they're doing. This is going to be pretty easy first problem here. So when we look at this question, they have y equals, or f of x equals, same thing, x plus 3 to the 4th. So as soon as we see that 4th power, we go, oh, it's even. We're talking about some kind of a U shape. Now, what does the plus 3 do?
Left
inside the parentheses like that.
Left 3.
Yeah, it's an x thing because it's inside the parentheses, right? If it was outside, if it was x to the 4th plus 3 like that, that would mean up 3, wouldn't it? If it was outside of the little x's world. But since it's inside, it's a right-left thing, and which one is it? Right or left? Yeah, it's opposite, huh? Because x always does the opposite. So plus is actually left. Minus would be right. X does opposite. If it was out here, it would be an up 3 because it would be a y thing. Anyway, so it's left 3. So we're saying, all right, so take a U shape and move it left 3. Which one of those is a U shape? Looks like that one. Moved left 3, huh? There it is. B, we're done. Don't even need to do anything else. Good? So it's 9, if you can see it, it's 9 halves x to the 4th. So x to the 4th is going to be a U shape. I guess they're all U shapes. What's that 9 halves going to do? That's a multiplier, huh? What do multipliers do? Yeah, they stretch. You know, it's going to stretch it up faster. Now, both these kind of look like U shapes. This one's probably right. It's stretched up. But how do we be sure? You can make a little table because they're showing you some dots. I don't know if you can see all that. I could make it bigger. But they're showing you little dots on there. So let's just make an XY table and see which one has the correct points. So I'm just going to do something easy like 1. You just plug in x as 1. Y, 9 halves, 1 to the 4th is just going to be 9 halves. So over 1 up 9 halves, yeah, that's right. So C's the graph, not the other one. Good on all that? Just a U shape going up fast. It's not these other two, because these guys have been moved. Right? That 9 halves, how would you make the 9 halves, what would you need to do with the equation so that you would get one of these guys where the 9 halves is moving the graph rather than just stretching the graph? Yeah, it'd have to be added, right? You'd have to add the 9 halves to go up and subtract to go down. That's not what we have. We have it times, so it's this one. It's been stretched up. You know all that? Okay, so they have x minus 1 to the 5th plus 8. Okay, so 5th power, it's a snake, right? It's a 5th power snake kind of thing. So what's this plus 8 out here going to do? Up 8. And what's this plus 1, minus 1 here going to do? Right, because it's opposite. X always opposite, so right one. So basically it's the snake that's moving, where the center, we're talking about the centerpiece, like this, the very center, the origin of the snake. has been moved right one, up 8. So if you grab the snake, and move it way up here, boom. Now, don't be confused by the tail. The tail will still be, down here, but the center. It's always about the center. In all these graphs, we're always grabbing the center like a handle, and we're moving it right one, up 8, way up here at 8. So, over 1, up 8. So which one of the graphs has done that? This one, right? Looks like that. See, the center is right about there. Looks like it's been moved right and way up. There it is. Is that good? So again, don't be thrown off by the tail part. Just find where the center has gone. Let's see. Small changes here. So y equals 2 minus x minus 1 to the 5th. Okay, 5th power snake. So it's a snake, but what's been done to it? What is this, what's this minus 1 going to do?
It's the right one.
We all good? That's right 1 because it's in the parentheses and x is opposite, so that's going to be right 1. What is this 2 going to do? Is that a positive 2 or a negative 2?
Positive.
Yeah, right. You look in the front, right? Their signs are in the front of them. Don't be thrown off by that minus. We'll get to that minus in a minute, but that's a plus 2. So really it's the same thing as if it confused you, just put it back there. That's the same thing. It's just a 2 added. It doesn't really matter front or back. So what's that plus 2 going to do? What's going to happen with that thing? Up 2, right? It's going to move it up 2. Up 2. Now, what about, let me just change the color here. What is this all-important minus sign, which is really a minus 1, minus 1 multiplying. Same thing, right? A minus sign in the front is a minus 1 multiply. You don't have to write it that way. Anyway, what's it going to do? Yeah, it's a vertical flip. It's going to turn the thing upside down, isn't it? Okay, now, here's the trick. Remember, when you do 2 things in the same direction, what I should say is when you do a flip and a movement in the same direction, the order matters and things get tricky. Right? If you move vertically and flip vertically, it matters which one you do first, which one you do second, where the thing will end up. Same thing if you do 2 things sideways. If you move it sideways and flip it sideways, it matters what order you do that in. It could end up in wildly different places depending what order you do that in. So they're not so simple. Remember, those are the super tricky ones? So those are the ones where I would just use a table. Because it's just too hard to try to, I gave you the rules once or twice and you could get them all down, but it's way easier just to say, I'm going to just use the table. I'm going to have the basic idea, and then I'm going to use the table. I think that's the easiest way to go. So I know. So when I look at that right one, I'm going to say or left one. Now why? It's supposed to be opposite. Yeah, but with the flip, if the flip comes after an original movement of right 1, then flipped, will end up looking like a left 1. But if the flip was first, then the right 1 will indeed be right 1 in the end. Do you see the problem? See how I'm unsure about the right or the left? Because if the flip comes after, the first right will end up being flipped to a left. But if the flip is first, you got it. I've said it twice. All right. So I'm just going to write right or left. I don't know. But I know there's up 2. No question there, because there's nothing else happening vertically. So, yeah, up 2 for sure. So, no way this guy, he's not up. Right? His center. We're talking about the center. The center is supposed to go up 2 and either right 1 like this or left 1. Oh, and flipped. So boom, boom. So I'm looking at one of those 2, not this. Everybody see what I'm talking about? It's either that or that. It's one of those 2. And a table will tell me which. Everybody with me on that? It's up 2. It's been flipped upside down. Right? It's up 2. It's either right 1 or left 1. You good? Now which one of those? So this guy's maybe. And this guy's may. No, both those guys are me. Yeah, they got them both. They're being tricky. They got both options. So it's one of those 2. It's not this guy. He's been moved down. All right, which one? Make a table. So XY table. You probably only need 1 point. Just plug in, 0 or 1 or something like that. Let me just plug in 0. So, or 1, 1 would be even easier because 1 will make that whole parentheses just vanish, huh? I'm just looking and saying, what's easy on this thing? We'll plug in 1. That whole X thing just poof, gone, right? Just plug in 1 there. Y is going to equal -1 times 1 minus 1 to the 5th plus 2. Y is 0 plus 2. Y is 2. Over 1 up to. Over 1, it's this one, isn't it? Over 1 up to. It is right 1. So the flip happened first. I mean, I don't bore you with all those details. The one that goes to the right, so it's this guy. Everybody see that? Not good? That'll be helpful for today, right? We'll have the same thing with a third power. I mean, we could. I don't even remember. All right, good. Questions on that? So use a table. So today when you're testing, if you're unsure about anything, use a table to be 100% sure, because two things on the same axis can be tricky. New here. So, all right, so form a polynomial with real zeros and degree are given. So, zeros, let me just write it here bigger for you, in case you can't see it. Minus 1, 0, 9, and the degree, let me scoot it over. The degree is 3. Okay. And type polynomial, then when we type a polynomial with integer coefficients and a leading coefficient of 1. All right. What does zeros mean? What's a 0? Yeah, that means at -1. I know we don't have to graph this one, but I'm just going to show it anyway. At 0, and we're over here at 9, it hits the x-axis. Zeros are x-intercepts. It's where the graph is at a height of 0. That's why we call them zeros. So that means the graph hits those 3 points. I don't know, what it does otherwise. It might, I don't know what it does. It might be like this, something like that. Somehow it's going through the x-axis at those 3 points. Does that make sense? So it wants me to type in a function that does that. How could I do that? Well, what will make x minus 1 be a 0? If you have x plus 1 as one of your parentheses. You see, if I plugged in minus 1, that would make that piece 0. And then plain x, or if you want x, it's always x with the opposite sign, isn't it? So x plus 1, plain x, and what's going to do the positive 9? X minus 9. Does that make sense how I came up with that? And put those in any order. The order doesn't matter. You see, if I plugged in -1, that piece would be 0. If I plugged in 0, that piece would be 0. And if I plugged in positive 9, that piece would be 0. So in other words, if I plugged in 9, for example, to all of them, I don't really care what happens to these two. That one would be 0, and 0 times anything means the whole thing 0. So plugging in 9 will make that whole function 0, meaning he'll be at a height of 0. The f function will be at a height of 0 at 9 when I make it that way, or at 0, or at -1. If you make one piece 0, the whole thing's 0, right? Because they're multiplied. So, okay, and that's all they want. Type a polynomial with integer coefficients, and leading coefficient. Let me get this out of the way here. Leading coefficient, so they want a 1 in the front here. Because really, there could be any number in the front there, and it would still do the thing they're describing. So they're limiting it to say, hey, let's just put a 1 in the front, or nothing. You don't need to put anything in the front here. It's just understood to be 1. And integer coefficients. There we go. So just like that. Does that make sense? On that, we made a polynomial that has those 0. And by the way, it is third degree. Why is it third degree? Because if you multiply these x's out, it'd be x to the third. Right? Are they okay with the parentheses answer? Or do they want it multiplied out? Do you know anybody do it yet?
Yeah, you have to multiply it.
You have to? Okay, so now they're saying zeros, and they're saying -3 with multiplicity. I'll tell you what that is. Maybe you already know. And then -1's another 0 with multiplicity. That's basically like the power is what that is. Degree of the whole thing is 3. So they want me to write a polynomial that does that. So the multiplicity is the degree, or the power, same thing, power on that parenthesis. So, in other words, let's say, okay, f of x equals, and how are you going to do the -3? Do the opposite sign, right? So it'd be x plus 3. Multiplicity 1, first power, or just normal. You don't have to put the 1 there. The next one, x plus 1, always opposite sign. Multiplicity 2, 2 power. That's all we're done. Does that make sense on that? So multiplicity means how many multiplied are there? right? Multiplicity 2 means there's 2x plus 1s, really. Anybody know what that's going to do? So that means if you plugged in -1, that piece would be 0, and since they're times, the whole thing would be 0. Or if you plugged in -3, that piece would be 0, thus the whole thing's 0 because they're times. So either one of those would be a 0 on the graph, right? Back at -1, back at -3. Those would be zeros on the graph, and it would, shoot up like that, and, And does anybody know, what does it mean when you have an even power on parentheses versus an odd power? Graphically, I mean. Does anybody know what that'll do on the graph at that 0 points when it's even instead of odd?
Shift the graph.
It'll bounce instead of passing through. So instead of passing through, it'll go boing, and this one it'll pass through. Why? Because even power is positive either way. You see, it won't go negative there, right? Because this is a squared term. So either side of that -1 squared, it's like absolute value or something. It's going to always be positive. That's what absolute value bounces things up, right? That's what an even power will do. It bounces instead of a pass-through. And that's what we're going to start noticing. In a minute, they're going to ask us this very question. They're going to say, show me which graph. So you should know right now, even powers bounce and odd powers pass through on the graph. Even powers, it bounces. Odd powers pass through on that. They're not asking me that yet, but they will. They're going to want me to be able to do a quick, rough graph. That quick, I know generally what the graph looks like. See the power graphically you're gaining? Just that quick, they just tell me this information, that equation, that's the general look of the graph. Like that. I know that quick. All right. All right, for the polynomial, so they're giving me, -8, x squared plus 16, x minus 4 cubed. List each real 0 and its multiplicity. Okay, so first thing is, now we're going the other way. So they're starting with the function, and they're saying, okay, now you tell me the zeros. A minute ago, they gave us the zeros, and I gave them the function. Now they're giving me the function, they want the zeros. So, all right, so what are the zeros of this function? So we're wondering, what a zero is x value plugged in to make the whole thing equal 0, right? So I'm asking, what x number could I plug, what different x numbers could I plug into that function that would make it 0? Certainly 4. We agree with that one first off? Right here. +4. If you plug +4 right in there, 4 minus 4 is 0. And you make one piece 0. They're multiplied, so the whole thing's 0. So x equals 4, certainly. Now what about this piece?
Would you have to consider -8?
Well, let's ask it. Would -8 work? If you put in -8 there.
When you have to distribute.
-8 squared plus 16. That's 64 plus 16. That's not 0, is it? So -8 certainly doesn't make that 0. Other ideas?
No, negative would.
Would 4 do it?
No.
4 squared plus 16. 16 plus 16. That's not 0.
0. 0 itself.
0 itself. Plug in 0 itself. Plug in 0. 0 squared plus 16. That's not 0. There's none coming out. Do you see that there's nothing there? What number could you ever plug in squared, then it's positive, right? And add 16 and get 0. You can't do that. There's no zeros coming out of this piece. Now, if it's because it's plus, huh? If it was x squared minus 16, then +4 or -4, either one, squared would be 16 minus 16 would be 0. It's because of the plus that's the issue, huh? Do you aware of that? So that's really important. I just made your second exam Monday, I think it was, and I put those on there because it's really important for calculus. This plus instead of minus, so make sure you're catching that. I know on your mind it's like, we're just taking the first exam, Mr. Aaron. I know, but be thinking about that. X squared plus, x squared minus. That's a big difference. That's a big deal as you move on to calculus. A lot of people that gives them trouble in calculus. I want to help you with that now. So the only 0 is 4. That's the only 0. All right, so now there's no other zeros. So question B, determine whether the graph crosses or touches. Yeah, they use cross or touch. I use bounce or pass through. Same thing, whatever. Cross or touch the x-axis at each x-intercept. Each x-intercept. So this is an x-intercept, isn't it? X equals 4. So that's the only x-intercept. It's the only 0. What's it going to do at 4? Is it going to pass through or is it going to bounce? Look at the power here. Odd, so it's going to pass through, isn't it? That's all the time we have.